Hi everyone, welcome back to Job 1 for All. In this video, we are going to see how we can throw the exceptions to whoever is calling your method. For that, let's start with runtime exceptions because it's easier, and then in the next class, we talk about the checked exceptions. So let's go back to our runtime.test, right click, Java class, and then runtime exception test 02. So let's imagine that we have the following scenario. We have a method that is a private static, is going to return an integer, and is called division. We have two integers, int a and int b, and we are returning a divided by b. So it's pretty straightforward, but the problem is, what happens if I call division and I say, for example, 1 and 0? Of course, you know that there is no division by 0, and this is going to throw a runtime exception, that is arithmetic exception. So basically, you know that there is a chance of someone trying to send an argument that's illegal, and you would like to avoid this. And we did that before, checking if b is 0, we were returning 0. But the problem is, it's not quite right. This is an exception, and we should tell whoever is calling, in this case the static void main, that something happened because an illegal argument happened to come to the division method. So when you have situations like this, you should throw a new exception. So basically, if b is 0, we would like to throw a new, and here we have the type of exception that should match exactly what we are trying to achieve. The exceptions, technically, they should not be any of the checked exceptions, because you should not force anyone to have a try catch for a division, for example, and it could be a runtime exception. And we could say here, the second parameter can't be 0. So basically, if someone calls division sending b with a 0 value, we are going to throw a new runtime exception. And you know that runtime exceptions, they do not need to be handled, but the problem is, if you do not handle, your program is going to crash. But we have here our exception now. It's not runtime, no, it's not arithmetic exception anymore. Now it's runtime exception, and we have a nice message saying the second parameter cannot be 0. But remember, it's always a good idea to be as much as specific as you can. And in this case, we have one that's exactly what we are looking for. It's illegal argument exception. So basically, you have to go through a little bit of the Java documentation and check the exceptions they have. Most of the time, the exceptions that you are going to throw, they already exist. But we are going to see how we can create our custom ones as well. So if you go to illegal argument exception, it is a runtime exception. And if you read the description, it's exactly what we are looking for. So now, if I execute again, we have another exception, that's illegal argument exception. So, as we saw when we were working with checked exceptions, we can also handle this case right here. So, for example, let's say that we would like to not just check, but we would like to handle with try catch. So we can add try, catch, and remember it was arithmetic exception, right? So arithmetic exception. So we can have return a divided by b, and if b is 0, I would like to print the stack trace. But we have a problem. Let me just comment this out. What's the problem? We are saying that we are going to return 0. Oh, sorry, we are going to return an integer. And we are going to try, if it works, we are going to return the division from a by b. But if something happens, we have a problem, because the print stack trace will be executed, but then it will just finish the method without returning anything. And that's why we have a compilation error. we have to return something in case a bad flow happens. And we can add it. For example, here, return 0. So this is just another way of doing what we were doing before, returning 0 if b is 0. But the difference is that here, now we will see the exception, and we are going to get the value. So if I add the salt here, you will notice that we will see the exception, arithmetic exception, but we still get the return. So this way, you know for sure that something happened, but also you get the result, the return that you are saying here. But the best scenario is doing like this. You check if the argument is valid. If it's not valid, if you know as a developer of this method that is not valid, you just throw the exception. And then if it's valid, it means if passed the if, then you can just return a divided by b. Now, you saw when we were working with IOException that sometimes you can add to your method signature like a flag saying, hey, this method may throw illegal argument exception. But this is not required. In this case, illegal argument exception is runtime exception, and runtime exceptions are not required to be handled. Even though if we add here, there is nothing that we can do for the main method to be forced to treat illegal argument exception. So remember, runtime exceptions, they are not checked. So even if you add a throws saying that this method may throw illegal argument exception, there is nothing we can do to force the method that is calling to handle that exception. So what you can do is like kind of just warn them, and you are not going to see runtime exceptions that much in the signature because again you cannot force them. So you can either leave like this, it's not wrong, but you can also add something as like a Java doc, and you can say, hey, param b cannot be 0, and then you can add here, for example, throws illegal argument exception if b is 0. And then whoever is calling, for example, division, if you press Ctrl Q, you will notice that we have like a small window with some documentation that's basically coming from here, and we have all the information that we need. B cannot be 0, and is going to throw illegal argument exception if b is 0. So as you can see, there are ways to tell other people what's going to happen in your method, even though you are not throwing directly here in the signature. Now, if you say some of the subclasses of exception, if you say, for example, throws IOException, then you are telling, hey, whoever calls this division must handle this method because it may throw IOException, even though we are not throwing anything here. Just by saying, just adding this kind of flag here, the method that is calling, in this case the main, must handle this through a try catch, or it can put the problem into someone else's. So if we go back to our diagram, so if I have my main method and here is division, so basically the division method, let me just delete here. So the division method is saying, for example, I may throw IOException. So if an exception happens, it will throw to whoever is calling, in this case main. But if main method does not want to handle, it can say, well, whoever is calling main, just be careful because there is an IOException that may be from this method. But we have a problem here. Whoever is calling main is going to handle, but nobody's calling main. We are calling main. So if we reach that point and some kind of exception happens, it is just going to crash your program because it is the end of the stack. But doing this way, you are not required to have try catch over the division method. Basically, you have two options. You either handle or you throw the problem to someone else. Let's do it here. And of course, if you are throwing illegal argument exception, you can also handle that illegal argument exception by adding a try catch here. But honestly, you should not do that. It's easier for you to do something that will actually fix the problem than trying to have like a workaround. Because even though you are adding try catch and you can finish the program successfully, you are just having like a huge workaround. If you execute this now, you will see that it's throwing a legal argument exception. We have a try catch. So if I add a breakpoint here, and then shift F9. So F8, as you can see, B0 is going to throw a legal argument exception. Then it's going to go back and go into the catch. It's going to print the stack trace, and then the program will finish successfully. So in this case, the only good thing is that the program is not crashing, but the whole idea of runtime exceptions is that you fix them before they happen. So here we can force things to not be zero. So if we are getting input from maybe a database or maybe someone else is inputting, we can check and give the exception to someone else. So we don't need to execute. We could do exactly the same thing. If someone is sending this to us, we could say in return, hey, you cannot enter 0 for the second value. So this is just defensive programming, what they call. So you prepare for the worst possible scenarios, and even though you are ready, someone will find an invalid argument to make your life harder than it should be. So that's it for today. In the next video, we're going to see how it works, but now with checked exceptions. So let's continue the next one. See you there. Bye.